Number 5. Why does electromagnetic radiation represent a larger energy transition than does radiation in the infrared region? Well, again, referring back to my response in number 4, okay, we need to understand that when photons are released, okay, they carry a certain amount of energy. We can calculate that amount of energy by measuring the frequency and then using the equation E is equal to h nu to calculate that energy level. That amount of energy, that quantum of energy. Then when we remember that the amount of energy present in a photon is equal to the difference in energies between whatever two energy levels between which the transition occurred, once we know that, we can actually calculate how much energy we got to calculate the differences between the energy levels, I should say. So again, to number 5, however, why does electromagnetic radiation in the ultraviolet region represent a larger energy transition than does radiation in the infrared region? Well, remember, according to the equation E is equal to h nu, energy is proportional to frequency. And ultraviolet radiation has a larger frequency than infrared radiation. To produce ultraviolet radiation, electrons must drop to a lower energy level than they do to produce infrared radiation. Okay, and so in order to produce ultraviolet radiation, if electrons must drop to lower energy levels, that means that they are having a larger transition, okay, in terms of distance from the nucleus. However, that distance traveled between those two energy levels is proportional to an amount of energy. So if there's a larger transition in terms of energy levels, that's going to correlate to a larger energy present in the photon. Remember, energy is proportional to frequency. That means you're going to have a larger frequency. Which, you guys should know by now that ultraviolet radiation has a much higher frequency than infrared radiation.